We're going to take a look at copying to points and instancing on points. I have a little demo object here, which is just a simple box with some axes here on the box, color-coded to match our axis here for world axis, but you'll see that this is actually in local space to the box, which we'll get into in just a second. So copying is typically done with a copy to points node. So I'm going to do a copy to points. And what you need is the object you would like to copy and then the points you would like to copy onto. For this, we'll use a grid and we'll place this straight down, enable it, and you'll see we get a lot of copies. One thing you'll notice right away is that this is probably pretty heavy. And the reason it is because it's making a unique copy of every piece of geometry in here, every point, every grid, every connection in here. And we have a lot of points. So now we have 15,000 points. One thing you'll want to do if you're making a lot of copies of something is enable this pack and instance option in here. What that does is it converts the incoming object into an instanceable object, which is then represented by a single point. And now when you come over here, you'll see there's only 100 points here. It does mean that I don't have access to the actual geometry that made up these. You'll notice I'm in primitive mode, but I can't select a primitive. I can only select a full object. However, if I want to do something like, manipulate this one object, rotate it, I can very easily. And if I wanted to get back to the geometry that's underlying this, I can simply put an unpack node here. And now it's converted it back into regular geometry, and I can go and start manipulating and moving points around. Everything else still stays instanced. Just this one becomes an object that I can actually manipulate. Now I want to do something here where I put down a mountain on our points that are coming in. And what we'll do is make the element size quite large and give us a big amplitude here. I want to point something out. You'll notice that the normals of our mountain have now become the orientation, the Z orientation of our box. And there's a reason for that. Let me go to this help file right here. And I want to show you this page. It is the copying and instancing points parameters, point attributes. And this has all the different attributes that will affect how your copied objects behave, how they are oriented, how they're scaled. I won't go through the time of reading all of this for you, but you really do need to understand all of it. And please note that multiple attributes can be used to control things like orientation and scale. And there are actually, there's an order of priorities in here, which is very useful to know. Now, the reason that our Z-axis changed is because it used the surface normals of the incoming geometry. Now, it's kind of interesting because we don't actually have normals here. So what it did is it pre-computed the normals of that surface, and then it used those. Now, if I delete the surface, so I'm going to use this add sop here, and I'm going to delete the geometry but keep the points, right? Points are still here. It doesn't have that information anymore. There is no surface to construct normals from, so now we're just back to our old orientation. So very useful to know. I'm going to delete that add, and I want to show you that we can write our own normals in here. I'm going to use an attribute wrangle. And here, I'm going to make our own normals. So we'll make an attribute, it's a vector attribute called n. And we will set this to point up in our world space. And there we go, we get the exact same kind of behavior. Now we can change our up vector, which is controlling which direction the y-axis is pointing. So right now, y is going to be pointing in that weird negative z direction. What if I want y to point in the world x direction? Let's do that. So we can say v at up is going to be equal to point in the x direction. There you go. And we can see that's our world x. And now the y orientation of our boxes is pointing in that direction. Let's set this back to something like a default value. So we'll say that y is up and z is pointing forward. There we go. All right, so there we go. That's a default value here. And we have other ways of adjusting these things. We can do something like an attribute adjust vector. And so here I could do something like just adjust the up vectors. So I can go find our up vector, and I can adjust the direction only of that vector. And here I can choose to spread. So I have my current value, and I'd like to kind of wiggle that value around by a noise value. So now we have our maximum spread angle. And you can see what we're doing here is we're wiggling that up vector around a bit. So z is pointing as it was supposed to point, but our y is adjusting. And then, of course, it's a noise that we have in here, so we can obviously change some stuff around, animate these things, etc. It's up to you. These things are just attributes, and you can control them however it is that you want. You can do the same thing with the z as well. So that would be our normals. So I can take our normal, and now I can do the exact same thing. I can just spread our normals. So now we're randomizing which way we're pointing. And remember, I just chose spread here, but you can also do adds. You can add to what's there. You can randomize completely with a seed number. There's a lot of variation for what you can do here. Now let's take a look at scale and how that works. I'm going to put down an attribute wrangle here. And we will make a float attribute called pscale. First, we're going to set it to 1. Actually, let's do it like this. Let's set it to a channel. So we will actually make a parameter for this. So we'll make a channel called scale. Actually, we'll call it uniform scale. I'm going to put a little bracket there. Now nothing's happening. We have an error because that doesn't actually exist. You'll see on our node we don't have that here, but if I click that button, now it's going to show up. And now I have a little slider that I can use to adjust the uniform scale. Again, we're just writing an attribute called pscale. If I go to our spreadsheet, you'll see that we have a pscale attribute. It's equal to exactly what we put in there. And we're adjusting that. We can even randomize that. So I can take that value and I can multiply that by a random number. All we need to do is tell it what is the seed that we want to use for our random number, and we'll use the point number in here. And now we have a slider here that controls the uniform scale, but we're also, again, further multiplying by a random number. Now let's leave that set back to 1. And let's take a look at another attribute here, just called regular scale, or scale without the p. Now this one's a vector, so we'll call that v at scale, and we'll make a channel vector, so chv, make sure you use the v, and we'll call this non-uniform scale. Now again, we're going to get a little error because that doesn't actually exist. And I might need to delete that dash out of there. Let's see if that does what I need. There we go. Didn't like that dash. All right, so I'm going to put that back to 1. And now you'll notice that we have scale as 3 separate components here. but these two values are multiplied together. So you can see as I adjust my uniform scale, it's a combination of this value multiplied by these values there. The cool thing is you can do random things with each of these components. So I could say something like I'm going to grab my scale attribute here, and let's grab just the y component. And let's say that is times equal. That means grab the current value and multiply it by something. So we'll multiply that by a random 0 to 1 value from our point number. And you can see we've only done that on the y scale. So there you go. You have a combination of position, rotation, normals, and up vectors, which are the easiest way to control the orientation and the scale and the positions of any copies that you make. Now, things can get a bit more complicated once you start wanting to work with matrices and quaternions and orient attributes, and that's not something that we're going to get into just yet. For now, the point of this lesson is to show you how these attributes work and what they control and how you can use them. But I urge you to play around with the various methods in Houdini of adjusting these values and these attributes and play around. Again, it can be as simple as using some of these attribute adjusts. Again, you want to grab the right attribute type. So a float attribute for something like p-scale. Check it out. It's already set up in there for you. And this just has a constant value. So again, you can set it just like that. Or you can go into a noise. Nice min and max value. You can change this to radial. There's just so many good options in here. Right, radial is great because it's basically like you have a built-in method here of moving things around, having like a small controller object in here. Very powerful. And this leads me to the next thing that I wanted to talk about here, which is an attribute transfer node. So I'm going to disable that scale in here. And I want to show you kind of a cool node that's out here, which is something called an attribute transfer. I'm going to make an add node in here. And I'm just going to add 1 point. So right in the middle of our scene, we have one little teeny tiny point. I'm going to put an attribute on that. I'm just going to, we'll do it with a wrangle. I love using wrangles. So we'll make a p-scale attribute, f at p-scale. We'll set that equal to 1. Okay. And here we want to make sure that we have a default value for p-scale, and we will set that to 0. So I'm just going to copy this. We'll paste it right in here. Let me grab that pipe. Come on, pipe. There we go. And we will set that to 0. All right, what I would like to do is be able to use this point right here with this attribute, and I would like these points to be influenced by it. So I'm going to use a transform here just so I can move that point around, have a nice little transformation handle. And what I'm going to do is put a node here called attribute transfer. And what this does is it has a distance-based lookup. It will find an attribute in this input on the right, and it will use a distance condition here. So here's our threshold to transfer the value into here. So I'm going to tell it that I would like to use the attribute called p-scale. And now I'm going to go to my conditions here. So max sample count is how many of the points in this other stream are going to be used and averaged together to transfer the attribute. We can keep that at 1 because we really only have 1 point. And then here we can choose the threshold in which that happens. So we can say something like that, and then we can blend that, which gives us a nice soft fall off. And now very quickly, we have made something that transfers this attribute from that point, from a little controller object, onto our scene here. Super easy and super powerful. And note that we can use that for anything that we want here. So let's say that we had an attribute here that was part of this, and we'll just call it effect. And we'll make that equal to 1. I'm going to double check something here. We have to make sure that we are also transferring effect as well. And what we'll see is if we didn't already have effect on here, it's going to get a value of 0. And where we do have effect, it should get a value of 1. And we might not have anything in between. Let me just quickly sort these and see. Yes, so we might want to add effect in here as well so that it can do the blend. So f at effect is equal to 0. And now you'll see we can get blended values. So you want to make sure the attributes would exist on both so that I can do a blend. Now we can use that effect attribute for something else. So let's disable the mountain here. And I'm going to put another attribute wrangle down here. And all I'm going to do is say that our capital P, our position, dot y, our y position, plus equals. That means it's going to equal its current position plus the value of our effect. And now as I move that through to here, you can see what we've done. We've transferred the effect attribute onto our template points. We have used that attribute to influence the Y position of the template points, and then we've transferred all that information to our copies. And you can keep going here. You can multiply that by 2. We could randomize that. We could do a whole bunch of other things. So we can, go up here if we wanted to, and we can say something like our at effect is going to change its value. We're actually going to randomize that. So take the current value and randomize that by our point number. And now we have applied that Y position, multiplied it by 2, and made sure that it's random for all of that stuff as well. So very, very powerful methods in here. So play around a bit. Experiment with some of these attributes. Experiment with copying things onto points. Make sure you understand how it all works, because it's going to become very, very useful to you in all parts of Houdini, especially once you start getting into things like particles and simulations and rigid bodies and stuff like that. It's very useful to understand the building blocks of all of this stuff. I wanted to quickly show a setup for how you would copy multiple components onto pieces of geometry, onto points of geometry. So let's take a quick look at the setup here as we start. I have 3 pieces of geometry. Got our pig head, test geometry, rubber toy, and then a template head. I've made them all approximately the same size. And I've put a center node in here just to kind of center everything together so that they're all centered around our world 0. And we will make a little point cloud for them. So just as before, we'll make a very simple grid and we'll put it right there. So when we do a copy to points, we can see that it will look for a piece attribute that we can use. In this case, it's looking for something called name. We could change that to anything we want, but we'll stick with the default for now. So when I click this on, what it's doing is it's looking for an attribute on the incoming points here called name, a string attribute. And if it finds anything with that attribute that matches on the inputs coming into here, then it will use that to figure out which copy goes to which point. So how do we make that name? Very simple. I'm going to make sure I turn on pack and instance, by the way. So there is something in here called attribute from pieces. And the way this works is we want to merge all the pieces that would be coming in into one stream. So I'm going to grab these. We'll merge those into one stream. Now we want to make sure that everything has a name on it. So I will grab a name SOP here, make sure it's set to primitives, and we'll give these meaningful names. So pig, we'll call this one toy. And that one will be head. Okay, now this is the point cloud. So the point cloud, we actually need to move this up here. The point cloud is going to be here. And this is the geometry library that is going to be coming in from our merged network here. So we can call this geo library if we want. Now, if we middle click here, we'll see that we have added a name attribute onto the grid points. So go to our spreadsheet and we can see what it's done. Now this goes into our point cloud here. And then finally, we can take our geometry library and we can pipe that into the first input, enable CopyToPoints, and we can see how that works. Now the alignment appears to have changed, so let's make sure that we also have some attributes on here that will influence the orientations. So I will just do a little bit of an attribute wrangle here, and we'll set some stuff up. So v at normal is going to equal that, and v at up is going to equal that. And that should get us back to where we need to be. If things are too big coming in, we can either shrink them here, or we can add a p-scale attribute and shrink here. So let's go ahead and do that with an attribute adjust float. So we have p-scale, and now I can set that appropriately. Now, the amazing thing about this attribute from pieces is that you have all these different methods for how you are going to determine which point gets which piece. Right now it's cycling, so it's just going through the same pattern. You'll notice we have the pattern head, pig, toy, head, pig, toy, head, pig, toy. And that's because this mode is set to cycle, but you can easily change this to random with offsets, random seeds, noise patterns, right, or various different methods in here. This is a very useful and very quick way of doing this, and the setup is really easy. It's something that you're going to use quite a bit as you're doing this kind of work in Houdini.